Well, believe it or not, there's actually a formula that you can use to find the vertex. So if we say the vertex are the numbers hk, where h is the x value of the vertex and k is the y value of the vertex, then it turns out to find the h value, which is the x value, all you have to do is figure out what is minus b over 2a. And then, once you have any x value, you can just evaluate the function at that x value to get the y value, the corresponding y value. So the vertex formula is just that the x value is minus b over 2a, and the y value is the function evaluated at minus b over 2a. So, go back to a problem that we just did, found the vertex by completing the square, and here you can see this function. The a is negative 3, the b is 12, and the c is also negative 3. So all I have to do is say, okay, I want to do minus b, so b is 12, so minus b would be minus 12, and then I divide that by 2 times negative 3. That's the 2 times a. Now minus 12 divided by negative 6 is just 2. So the x value of the vertex is 2. And all I have to do to find the y value is plug this 2 back into this function. And that's actually pretty easy to do, because if you plug 2 back into that function, you get negative 3 times 2 squared plus 12 times 2 and then minus 3. And so that would actually be, let's see, that would be negative 3 times 4, so that's going to be negative 12. 12 times 2 is 24, so it'll be plus 24 minus 3. And I'm sure you can take it from there and figure out that that's just going to equal 9. So the y value is 9, so therefore your vertex is just the point 2, 9. Okay? Now, I also want to talk about how to find the maximum or minimum of a quadratic function. Now, a quadratic function will either have a maximum or minimum, but it really depends which way it opens. So if you go back and look at this one, notice this one, it opens upward. So if a is positive, in this case a is positive, so the graph opens upward. So when a is positive, you actually have a minimum. I'll just write min for short here. But you have a minimum if a is positive. And then look at this one. Remember, on this one, since it opens down, we know that a is negative. So when a is negative, you actually have a maximum value. In other words, you have a highest point in that case. But actually, notice where the minimum for this one is and the maximum for this one is. It's just at the vertex. So, and since we're talking about minimum, maximum is talking about the height, so the minimum would be the y value of the vertex, not the x value. The x value is just where it occurs. So the minimum for this function would be negative 6, and then the maximum for this function would be positive 9. So again, the minimum here is negative 6, the maximum is positive 9. So actually, to find the minimum and maximum of a function, the first thing you need to do is make sure you know which way it opens, so you know whether it has a minimum or maximum, and then just find the y value of the vertex. So if you go back to the one that we just did, we know this one opens down, right? So it looks something like that, and so therefore it must have a maximum. And we know the maximum must be at the vertex, so we find the vertex like we did before using the vertex formula, and then we say the y value is the maximum. Okay, now here's another one. This one has a fraction in it, but it shouldn't scare you too much. Here, the a is the negative 1/3, the b is the negative 12, and c is 15. So if we do minus b over 2a to get the vertex, we get minus negative 12 over 2 times negative 1/3. Well, that's actually going to equal, let me show you this over here, that's actually going to be 12 divided by, 12 divided by, what's negative 1/3 times 2? Isn't it negative 2/3? Okay, so now let's think about when you divide by a fraction, don't you just multiply by the reciprocal? So we would just multiply by the reciprocal of negative 2/3, and then that would equal negative 12 times negative 3 is negative 36, and then divided by 2, we would get negative 18. Now that's not the minimum. That's not the minimum. That's just where the minimum occurs. So actually, and by the way, the reason I knew minimum was because this one opens down. So I'm sorry, I said minimum. This one opens down, so it has maximum. So both of these actually have a maximum. I thought I did one with a maximum, one with a minimum, but actually both of these have a maximum. So this opens down, and so it has a maximum, but the maximum is not the negative 18, that's the x value. The maximum is actually the y value that you get when you plug this negative 18 here into this function. So I'll let you do that. You saw me evaluate the other function at the x value. So just take the negative 18 and plug it in here for z, and also plug it in here for z, and then just grab your calculator. And so you'll have negative 1/3 times negative 18 squared minus 12 times negative 18 plus 15. And actually, when I did that, I got positive 123 for the maximum. So the maximum is the y value 123, and it occurs at x equal negative 18. So again, both of these actually had a maximum. But remember, if the if the coefficient of the squared term is positive, had this been a positive 1/3, then this graph would have had a minimum instead of a maximum. Okay, so that shows you how to do the vertex formula to find the vertex, and how to determine the maximum and minimum of a quadratic function. So we're almost done with quadratic functions. I'll do one more video on some applications of quadratic functions, and then we'll be finished.